Okay. So a pure virtual function is a virtual function that has no definition in the base class. To create a pure virtual function, the syntax is virtual. Virtual is a keyword here. Okay. The word virtual is a keyword. So I have to write in lowercase letters, just like word class. So here virtual is a keyword, and type is nothing but a data type. That is the return type of a function. See, whenever we come across the functions concept, so we have to write the return type. Okay. So in normal functions chapter also we have discussed about that. Okay. So before writing the function name, so we have to write the data type, and that data type is nothing but the return type. So in this case, you have to call it as a return type. So instead of data type, if you call return type, it will be good. Okay. So virtual is a keyword. Type is the return type. Function name is nothing but identifier. So any identifier I have to give valid identifier. So by remembering the identifier rules, that is blank spaces not allowed, keywords not allowed, underscore symbol is allowed, but other symbols are not allowed, and starting character should not be digit. So by remembering these rules of identifier, then you have to write the function name. That is nothing but an identifier. Then parameter list. So if there are parameters, then you have to write parameter list. Otherwise, simply you can leave it as blank. So in functions, there are two things: without the parameters and with parameters. So here it is also called as argument. Okay. So if we want to create a pure virtual function, so I have to write the equals to 0. Okay. Otherwise, what happens? So now if I write this much, it is not called pure virtual function. It is a virtual function, but it is not a pure virtual function. The example will come to know. Okay. So if we write only this much, it is not a pure virtual function. It is a virtual function. That's all. Now if I write equals to 0, okay, then it is called pure virtual function. Okay. So now we will see. So what is the property of pure virtual function? Fine. See, when a virtual function is made pure, any derived class must provide its own definition. If a derived class fails to override the pure virtual function, a compile time error will occur. See, first of all, before we go to this example, say, uh, there are some situations in a programming language, especially in C and C++ and Java, so where we come across this concept, that is, see, now if suppose if I write the class, so if suppose if I write the class A, let me consider one class here, then okay. So in public section of class, if suppose if I write two functions, let me say void display, and I will put semicolon. So if you put semicolon, it is called as prototype. Okay, prototype. That means complete function is not present here. Now, if suppose if I write one more function, say void print. Okay. Now here for this I'll write the complete function. That is opening brace. Then we'll write the code. Okay. Let me consider. So this code is present inside the class. This code is present inside the class, or this function is present inside the class. Anything. Okay. We'll come to know this complete function is present inside the class. Next, so I will close the class. See, one more function left here. I have to write. That is for display. I have to write the code because I have not written the code. So for print, I have written the code. So at least one sentence we write within opening brace and closing brace. Also, that is code of the function. Otherwise, code will be not present. So you should call only prototype of the function. Now, outside the class, I can write the code. Void. Mention the class name. Scope resolution operator. Write the function name. Display. Then cout. Okay. I can say this code is present outside the class. Okay. So this is how we write the program. Okay. Next, see, if suppose if there is an inheritance concept, now I can take one class called as class B. Okay. Class B public A. So B is the derived class, A is the base class, and this colon indicates we are linking in the sense inheritance thing it is. So this is the inheritance mode. Public is the inheritance mode. So just observe the symbol colon and double colon. So when we use the double colon, it is a scope resolution operator. So when you use single colon, it is used for inheritance concept. Okay. Now the thing is, see, whenever derived class is inherited, that is from the base class, see in the public section, you can write the new function. Let me consider like void output. Okay, void output. So we'll write here. So see out. So this function belongs to class B. Okay. Okay. Now, see, I have said that B is the derived class. The meaning of that is, so public members of the base class, that is print and display, becomes the public members of the derived class. So that we have understood from the inheritance concept. The meaning of that is, as good as I am writing like this. As good as I am writing, I will copy this and I will put in the derived class and even display also. That means actually while executing the program, this doesn't happen. See, when I explained inheritance, I have said it doesn't happen, but we have to understand like this. Okay. So the meaning of that is both these functions belongs to class B in the public section. That means public data members or functions of the base class will become the public data members or functions of the derived class. Okay. Now, I hope you people have understood. So let me remove this. Okay, because we have to understand like that only. For your understanding purpose, I have written 1 second. Okay, so just you have to understand public functions. That is, print and display will become the public members of the derived class. Okay. See, now the question is, if suppose, see one more time, if I write the print function, okay, and open brace. Okay, so one more time if I write like this, already print function is present in the base class, already it is present, and if I inherit, automatically it will become the public members of the derived class. But still, if I write one more time without any change, that means without any change means data type is also same, function name is also same, parameters is also same. If you have to look at this first line, okay, without any change means data type, function name, parameters, and within parameters, in the print function of class A, I have not given anything. In the print function of class B, I have not given anything. That means function is same. If we compare, function is same. So this also we can do. That means even though one function is already present in the base class, same function name you can use in the class B, that is derived class. Same function name means signature. Signature means this line indicates signature or header of the function. Remember, this particular line indicates signature, or we can call header of the function, signature or function header. So if there is no change in the function header along with the data type, function name, parameters, and inside parameters, if there is no change, for example, if I use int a, and in the class B also if I use int a, if there is no change, these type of functions are called as virtual functions. Okay, these type of functions are called as virtual functions. That means we are using same signature for the second time in the class B. Okay, same function name. For that, what we have to do, we have to write the first function by the keyword virtual. So the meaning of that is, even though the function is present in the base class, in the derived class, if I want to change the code means functionality itself I want to change, that we can do by using the concept called as virtual functions. If I don't use the concept virtual function, then we may get error at this line, because already this function is present in the class A. We may get error at this line. So for that purpose, what we have to do, if I want to change the code, I have to write the keyword virtual. Okay, I have to write the keyword virtual. Okay. Next. So changing the code means, so you just observe here. So I'll take this code. Okay. So let me take this. So this code is present inside the class. I write B. Okay. And one more statement I write cout. Just I write the word inherit. See, if there is a change in at least one letter or one statement also, then we can say code is changed. Okay, that means whatever the code present in the class A of print function is different from the code present in print function of class B. So whatever the code present in print function of class A is different from the code present in print function of class B. So these type of things are called as virtual function, and this method is called as override. Okay, see, they are using the word in the document, that is override. See, look at this sentence. When a virtual function is made pure, any derived class must provide its own definition. If a derived class fails to override meaning changing the code. Okay, changing the functionality. Override meaning changing the functionality. Function name will be same. Okay, data type, function name, parameters, everything will be same. Code we will change. So if we change the code from base class to derived class, that is called as override. In Java also we come across this concept, method overriding. There we will call it as method overriding. So here we will call it as function overriding. Okay, function overloading is different, function overriding is different. So I will tell you later difference. So here method override. Okay, now in this case also one more method is there, that is so this is virtual function. As I said, this is virtual function because from class A to class B we are changing the code. So if there is a change in the code, for the first function, what you do, you write the keyword virtual. Okay, so virtual is the keyword, void is the data type, print is the function, this is the argument list. Next, see, if we want to do like that, so this is the virtual function and they are calling it as pure virtual function. So pure virtual function means, if suppose if I am writing one function, say void, let me say input, and tell one function name input. Okay, now, so if I write some statement, say scene A, variable A, variable B. Okay. Okay. Now let me think, like I want to make this as a virtual function. That means I will take the same function name, data type, everything. One more time I will write in the class B, but code I will change. See, if you change the code, so that concept is called as virtual function. Okay. I write scene. So instead of AB, I will write it as CD, D variable. And one more line, even I write scene E. So I have changed it. Code I have changed. If you compare, here scene extraction operator A, extraction operator B, semicolon. Here scene extraction operator C, extraction operator D, and again one more line, scene E, F I have used. That means there is a change in the code. See, if you are using the concept of virtual function, there are two methods. Writing in this way. Another way is make it as pure virtual function. Pure virtual function means, if you are changing the code in the class B, that is derived class, so instead of writing the code, leave it as it is. Don't write anything. That means in the class B, we will change it. Only thing what you have to write, data type, function name, parameters. That means only signature you write it. Don't write the code. So I'll write here. This is called signature or function header. Okay, signature or function header. So if you want to apply virtual function, so instead of applying normal virtual function, make it as pure virtual function. Pure virtual function means what? In the class B, just write the prototype. Don't write code for that. Okay, don't write code. Then in the class B, anyways, you're writing the code. So this type of coding is called as pure virtual function. So if we want to make it as a pure virtual function, here what you do, add the word virtual. Anyways, we are making it as virtual, and data type is there. Virtual data type function name is equals to 0. See, here we have two virtual functions. Print is one virtual function, input is one virtual function. For print, we will not call it as pure virtual function because code is present here. Code we are changing in class B, but initially it is present. In class A it is present. But for input, there is no code. So we are directly writing the code in the class B. So it is called as pure virtual function. See, whenever we write the prototype, for example, void display, void input, like this, these things are called as a declaration. Okay. There will be no implementation. Implementation means if you write actual code of the function, that is called as implementation. So these type of codings are called as declarations. And if you write actual code, then complete function will, we can say it as definition. So there is a difference in the declaration and definition, particularly for functions. So if you don't write any code for the function, it is called a declaration. If you write the code, it is called as definition. So wherever you say definition, there will be implementation. So actual task what we're doing will come to know. Okay. So now if you just follow the syntax here, okay, you just observe the syntax. See, virtual is a keyword. Okay, this syntax you have to follow. Virtual is a keyword. Type is the data type. Function name. Parameter list is equals to 0. If parameter list is there, you should write. Otherwise, no. So same thing I have used in the example. You just observe here. For the second function input, virtual is a keyword. Void is the data type. Input is a function name. Within that, if there are parameters, you write. Otherwise, no. Equals to 0. Now we will go for the example in the document. Okay. Okay. So when a pure virtual function, when a virtual function is made pure, any derived class must provide its own definition. I said definition means writing actual code. Declaration means where there will be no code. If a derived class fails to override, then for the pure virtual function, a compile time error will occur. See, the meaning of this is in this example only. See, have written void virtual void input equal to 0, right? I have not written code for that. So what I should do is in the derived class I should write the code. If suppose in the derived class if I don't write the code, then we will get error. So that only they are telling. If a pure virtual function is not, if for the pure virtual function if code is not present in the derived class, then we will get an error. So override meaning writing the code for that. So if this line is present, then will not get any error. If it is deleted, we get error. Okay. So in the document, we will see the example. So the following program contains a simple example of virtual function. So we will see what it is. Okay. So I have taken the class called as number. Inside this class, I have the one protected variable, okay, protected data, protected access specifier variable, one function which belongs to public section. Okay. Now you see, comments you see, show is a pure virtual function. That means I have written virtual keyword void data type show function name equals to 0. If I write equals to 0, it is nothing but pure virtual function. Okay. If suppose if I use this set val function in the derived class, if I want to make it as virtual function, then we can write virtual, but it is not called as pure virtual function because complete code is present. Okay, and it is not compulsory that you should make it as virtual function. You can leave as it is. If you want to make it as virtual function, two ways are there: write complete code and change the code in the derived class, or you just write only one line of the function, then you change the code in the derived class. Okay. Now let me consider set val is not a virtual function, whereas show is a virtual function. Now, if you observe this show function, wherever it is used in the derived class, code will be present. You just observe here. See here, hex type. That means hexadecimal. It is called as hexadecimal. So in this class also, I have used the function called as show. Then again come to the DEC type, that means decimal number type. In this class also I use the function called as show. And again oct type, octal number. In this class also I used a show function. That means say I am inheriting the base class number in by three classes, that is hex type, DEC type, oct type. These three classes inherits the properties of base class number. Okay, we can say like multiple inheritance it is. Okay, one base class, many derived classes. Okay, so we will see what is the type of inheritance. We have the diagram, right? Sorry. Let me open the inheritance thing. Just will come to know. Okay, you observe this diagram. See, five types of inheritance: single level, multiple, multi-level, hierarchical, and hybrid, right? See, in case of hierarchical, base class will be one, but derived class will be more. One base class, derived classes are more. A is the base class, B, C, and D are the derived classes. Same thing we are using in the present example. That is, in case of virtual function, just a minute. See, in case of virtual function, what we are doing, okay. See, base class is 1. Base class is what? Number is the base class. Okay. Coming to the derived classes, hex type, this is the derived class. DEC type is the derived class. OCT type is the derived class. Okay. Hexadecimal type, decimal type, and octal type is the derived class. So, one base class with multiple derived classes. So, this concept is called as hierarchical inheritance. Okay. So, here I can write in this program what I have used is hierarchical inheritance. So out of five inheritance, we used hierarchical inheritance concept here. Okay. Next, coming to the set val function in the base class, we have not used in any of the derived classes. That means automatically we can call this function because you just observe this line. Hex type is the class name, right? Derived class name, right? Public is the access specifier. Number is the base class, right? See, when we use in this format, if the inheritance mode is public, at the time of execution, how we can consider is, we can consider this function as it will become the member of derived class. It will become the member of derived class while execution. Okay. See, in the program we will not write, but while executing, you have to understand like that. It will become the member of public member of the derived class, because when we use the inheritance mode as public, so public members of the base class will become the public members of the derived class. So in case of hex type, and again in case of decimal type, and again in case of octal type. Okay, this is not virtual function actually. This is normal function. At time of execution, we can consider like this. Coming to the show function, it is a virtual function. So we have written the code for that. So according to the requirement, we have written. You just observe here. So in oct type, code is OCT VAL. OCT means it will convert to octal number. The meaning of OCT is it will convert to octal number. So in decimal, direct value have written. So if you don't use any conversion thing, by default it will be decimal numbers. Decimal numbers means from 0 to 9, they are called as decimal numbers. Okay, from 0 to 7, octal numbers. From 0 to 15, hexadecimal numbers. And in case of hexadecimal hex type class, I used HEX. HEX means it will convert to hexadecimal number. Okay. So show is a virtual function, whereas set val is not a virtual function. Just for our understanding purpose, we have to think like this. It will become the public member of the derived classes. Okay. When we execute this program, we will see what happens. See, program execution starts from the main function, right? Next, you observe here DEC type D. That means, see here, D is an object of type. That means of class, we can say type or class DEC type. It is an object of class DEC type. Okay. Then coming to the H. So H is the object of class. You can say H is the object of class HEX type. So we have 4 classes totally. Okay. Next, coming to the O. So O is the object of type OCT class, OCT underscore type class. Okay. Now, D dot set val. Okay, D is the object of DEC type class, whereas set val is the function of number. Okay, D belongs to class DEC type. Set val belongs to class number. So there is no matching here. So object belonging to one class and function belonging to one class. But still we will not get any error at this point, because so it is the inheritance concept. So it is inherited. Inheritance means so it will become the public member of the derived class. So if you observe this diagram, so you will come to know how it is executed. Okay. See, DEC underscore, sorry, D dot set underscore val. So 20 will be copied to I. Okay, see, I have written the numbers in circles. That means in this way we have to consider the execution 1, 2, 3. Okay, so 20 will be copied to variable I, and I will be copied to VAL, and finally we get for object OB VAL value is 20. Sorry, here object not OB, it is D. Object is a D here. You should consider it as D. So for object D, for variable value is 20. Okay. So that is the meaning of D dot set val. Okay. Then that value will be displayed. D dot show. So that value will be displayed. So first you have to set the value, then it will be displayed. Similarly, H dot set val. So 20 will be copied to variable I, and that I value will be copied to VAL. So object H is created. For object H, variable is VAL, and that value is 20. So here 3 objects are declared, created. Object D, object H, object O. Object D refers to DEC type class, H refers to HEX type class, O refers to OCT type class. Okay. Now, see, when the value is copied, while displaying what happens, this 20 will be converted to hexadecimal format. 20 will be converted to hexadecimal format. Okay. So hexadecimal format of value 20 is 14. So it will convert. So there are some conversion methods here. Hexadecimal to any other number system to decimal. Okay. So in that case, it will be converted to hexadecimal. So hexadecimal format of value 20 is 14. Coming to the O dot set val. Okay, O belongs to that is an object of class OCT type. Now again 20 value is passed to variable I will be copied to VAL. For object OB, VAL for variable VAL value is 20. While displaying, it will convert to octal format and it will display. So octal format of 20 is 24. So it will convert to octal format. Okay. See here, more than conversion, what you have to understand in this program is, see, set val function is called on all the 3 objects D, H and O, because it is the derived class and it will become the public member of the derived class. So you can call. And show function in all the classes we have written. So directly if you say D dot show, H dot show, O dot show, it will call the functions present in those classes. Okay. See, if you observe, show function is present in DEC type class. Again, show function is present in HEX type class. Show function is present in OCT type class. Whereas set val is function is present only in the class number, which is the base class. Only in the class number it is present. That is the base class. So only even though it is present in the class number. So if I call D dot set val, H dot set val, O dot set val, functions will be called because inheritance concept is there here. So DEC type class, HEX type class, OCT type class, those are the derived classes. By using derived classes only, you can call the functions which is present in the base class. In case of show function, there is no confusion at all because these functions are present in each classes. Okay. And I will see D dot show displays 20 decimal number, H dot show displays 14 hexadecimal number, O dot show displays 24 octal number. Now I will execute this program. So after the execution, if you come across any doubts, you can ask. So I will share this screen and I will execute. Okay. Okay. So this is the function. So this is the program I have written. Okay. Okay. So first time I will execute complete program at a time. Okay. If you observe, so 20, 14, 24, these values are printed. So 20 is the decimal value, 14 is the hexadecimal number, 24 is the octal number. Now we will see line by line execution. Okay. So program execution starts from the main function. Clear screen. So object D is created, object H is created, object O is created. So D dot set val. You just observe how program control flows directly to the base class because set underscore val, this function belongs to base class. D object D belongs to derived class. Derived class DEC type. So object belongs to derived class, set val functions belongs to base class because inheritance concept is there. So program control can go to the base class. See here how it is passed. So 20 will be copied to I and again in turn I will be copied to VAL. Okay, you just observe it. Okay. Now, okay. Here we can test the object D. So let me try. See here. So when I tested the object D, so D contains VAL variable, object D contains VAL variable, value is 20, and also see on the top right corner it is displayed. Object D can access the functions setval show. Okay, two functions it can access, setval and show. Okay. Now see the program control is moving to the show function of DEC type class. So show function is a virtual function. Okay. Then h dot set val. So again, h dot set val means set val function is a base class function and h is the derived class object. Just observe. Again, it is moved. Okay. So value of I is copied to VAL. Now you can test this object. H. Okay, H contains value 20. So by using all the objects, we are passing the value 20 only. While displaying, it will change. Okay. Okay. Now O dot set val. Okay. So O dot set val means again it will be called O dot show. So show function of OCT type class will be called. So this is the end of the program. Okay. Okay. Bye. Okay.